Okay, now, okay, definitely. All right, so I've redrawn this so it's a little easier to tell. Oh yeah, I got two triangles. One's got, you know, they look like they are the same shape. One's just bigger than the other, and there's kind of three distinct sides. So one of the things I'm doing to make this a little easier is to redraw it. And then the other thing that might make this easier is, you know, these are our numbers up here. Are the sun to the Earth is 149 million. Our sun to the, oh, my mouse is giving me problems this morning. From A to S, which is this right here, I'm going to change this to the diameter, which is half of the number they gave me. I'm just going to use from the center to the edge is the radius, which is another word you should know, versus the diameter, which is all the way across. And I'm going to do the same thing with the BM, which is the from the middle of the moon to the edge there. So we're going to use the radius instead of the diameter, just to go with my better picture. And then I'm like, well, these numbers are still pretty hard. What if I chopped off 3 zeros? I can do that. I can divide by 1,000. So sun's about 150,000. The diameter of the sun is about 7,000, and the diameter of the moon is about 1.75. This makes this a little easier to do. So if I was going to label this thing, now a little bit easier because my numbers are a little bit better. I've got a better picture. This thing they gave us to start with seemed a little too difficult. So I'm going to say, you know, this long thing here is 150,000. This thing's about 7,000, and this little guy right here is about 1.75. Now notice this is not to scale, because otherwise that 1.75 and that 7,000 don't make sense in the same thing. This area here should be incredibly much longer. It should be way off the page for this to look to scale. So that's why the 1.75 and the 7,000, if those don't look right to you, it's because they're not, because it's not to scale. But the triangles would be similar. Okay, now this is still a little harder than I would like it to be. So I'm going to do one more thing just to make the problem easy. It's going to give me the wrong answer. But just to make it easier, I'm going to say, hey, instead of 150,000, I'm going to make this 15. Instead of 7,000, I'm going to make this 7. And instead of 1.75, I'm going to make this 2. Now, I've completely changed my numbers. It's going to give me a wrong answer, but the setup is going to be right, such that later when I come back and plug in my original numbers, I'll know where everything should go. And this is really important, and we're going to spend time doing this today, which is why I'm recording it right now. So we have to set up what's called a proportion, which is the ratios of two sets of corresponding things. So this is a proportion. It's two ratios. And as a reminder, a ratio is simply, you know, a fraction. Okay. And I got a question in the chat, so I'm going to check that here. Oh, okay. Thank you. All right. So I have to pick up some matching pairs. Now, there's more than one way to do this, but I see a matching pair, and I'm going to change colors again. I see that 7 and this 2, those two sides correspond to each other. One's small triangle, one's a big triangle, they correspond. So I'm going to do, I'm going to do little over big, or big over little, big over little. So I'm going to do 7 over 2 is equal to, and then my other sides are, I got this long side here, which is 15. And I'm actually trying to figure out this side right here, that M to E. So I could call that M to E, I could call it X, I could call it whatever I want to. Okay, this is now a proportion that I can solve. And some of you may remember how to solve this, and some of you may not. Most of you might. Anybody, when you see this, know what the method that we typically do to solve this thing is called? I would love somebody to type that in the chat window. What's it called, the step we usually go through here to solve for our X when we've got a proportion like this? So typically, I think most of you, somebody just did it, thank you. Cross multiplication, yes. Now cross multiplication seems like a magical thing, but it's really not. Cross multiplication is really just a way for us to get rid of our fractions, because fractions are kind of a problem to deal with. So if I want to get rid of the X, I can multiply both sides by X, and the X will cancel, okay? Multiply both sides by X, oh, that X goes away, it's over here. And if I want to get rid of this 2, if I multiply both sides by the 2 over here cancels. So I got X times 7 equals 15 times 2. No fractions, much easier to solve. Now, in reality, what most people do when they do this is they don't do what I just did. They actually circle things. Say 7 over 2 equals, supposed to be a 2, not a z, 15 over x. Say they say, oh, grab those two, multiply them together. That's where my 7x comes from. Grab those two, multiply them together. That's where my 2 times 15. That's what it normally looks like, which you're going to see me do a lot today. But the basic idea is you're multiplying both sides by one denominator to get it out of the denominator, so it ends up on the other side, and you're doing the other. I like to point out why this works, because most people think cross multiplication is magical, and it's not. It's just a way to do 2 steps at once. Instead of multiplying by x and multiplying by x and writing a new step, and then multiplying by 2 and multiplying by 2 and writing a new step, you can do it all at once. So I got 7x equals 30. I divide by 7, and x is equal to, let's see, I'm going to have to drag the calculator out. 37. So what are 37? I'll go to my phone and bring up my calculator. And 30 divided by, oops, that's not going to work. 30 divided by 7 is 4.3. And if we look at this picture, that should make sense given the numbers that we've got. So we had our 15, we had our 7, we had a 2. That's 2 is less than half of 7. So this number should be less than half of 15, which it's 4.3, which makes sense. If I came up with a number bigger than like 7, because half of 15 is 7.5, that's probably a mistake. If I came up with a really small number, like 0.2, that's probably a mistake too, because I'm saying well, that's slightly less than half. In fact, it's about a quarter. So it's always important to think about your answers and like, was that the number I was expecting? Does it kind of fit? Because it's easy to set this up wrong. If I had done 7 over, I think 15 equals 2 over x, I think that would have been maybe. There are ways to set this up wrong if you don't think about, I need matching parts, I need big over little, to big over little, or little over big to little over big. You've got to set it up right. Otherwise, your number probably won't make sense, which is nice because you can say, oh, wait a second, I did something wrong. I typed my calculator wrong. I set it up wrong. Okay, now if I wanted to, I could say, oh, well, let me go back and solve the original problem now. It's the same thing. The original problem I would put in using my adjusted numbers. In fact, I could do it with the original one, but if I do it with my adjusted numbers, which were pretty close, 7,000 over the 1.75 equals, what did we decide, 150,000 over x. And now when I cross multiply, I get 7,000 x equals whatever 1.75 times 150,000 is. And that's a little bit of a mess. I'm going to do that in my calculator. 1.75 times 150, 1, 2, 3, and then I'm going to divide that number by 7,000. And I get 37.5, which let's think about if that makes sense. If this was 150,000, which is a really big number, I would expect this to be a really small number. I'm not quite sure if 37.5 makes sense. And once again, remember, that's our actual answer would be 37,500 because I had divided everything by 1,000. So that would be the approximate answer, I think. Probably, my guess is this is pretty close to how far away the moon is, because usually they do pretty good, good answers in here. Okay, so that was a very complicated intro to what you're going to get a little more time to do, and I've got it recording now, and I'm actually going to record one more thing, which is us going through. All right. So our goal here is to talk about similar, what that word means, and it actually has 2 meanings depending on the context you're using it is. One's math and one's what you probably already know what it means. And then we're going to solve some problems involving scale factors, ratios, and proportions. And the last 10 minutes of class, I'm going to give you a very short quiz. And most of you who've been doing those forms at the end every day are going to say, man, that was easy. You should give us more quizzes like that. And those of you who have been kind of not paying attention to those, you're going to be like, oh, I knew some of this, but I should have known more. And we'll figure out what to do if you're not happy with the score. But I am going to do that the last 10 minutes of class. But we're going to give you hopefully lots of time to practice here. Okay. So first of all, similar has 2 meanings. So I would like everybody in the room to type a few words around what you think the word similar means. And I don't care in which context. It can be in the math context or in just you use it in everyday language. But I would like everybody in the room to type and answer into the chat. So I got 1 answer, 2 answers. I haven't even looked at it. 5, 6. I just see answers popping up there. I'm not even looking at the chat. I got 8, 9, 10, 11. Thank you for all those people who are typing. Okay, now I'm going to go see what people said. We got same, alike, close to equal, the same, alike, alike, alike. It's mostly the same, alike, almost the same. Yes. Proportional, the same. Okay. So in everyday language, it means the same. It doesn't mean exactly the same, but it means close to the same. The same means actually they're exactly the same, to me anyway. Similar means, they're close. They're not exactly the same, but they're pretty close. That's what it means in everyday language. Okay. So I said akin, which is a word you probably won't hear very often, but it's a crossword word, and I do crosswords a lot. Akin or alike, but not the same. They're very close. And in geometry, it means figures with a scale factor or ratio that relates them. And basically, they are dilations. This is the word that we've been using probably up until now. One's an enlargement of enlargement, or the other is a reduction. So a similar figure is one that, it's kind of the same shape. It's just much bigger, or it's much smaller. And it means that all the parts, all of the sides have been multiplied by the same thing. So an example real quickly is I might have a triangle where the sides are 3, 4, and 5. And then I might have a much bigger triangle where the sides are 6, 8, and 10 because the scale factor is 2. And that scale factor can be anything. And one of the things that we kind of talked about briefly last week, if that scale factor is actually less than 1, so it's like 0.9, that would actually mean it would be getting smaller. So, or like 0.5. Like if I had a 0.5 scale factor, this thing could also be similar to one where the scale factor was 0.5, in which case the numbers would be 1.5, 2, and 2.5, because I'm essentially multiplying by 0.5, which is the same as multiplying by 2. But a scale factor means multiply, so it's what I'm multiplying by. And so if I want to make something smaller, I actually multiply by a fraction that's less than 1. It's like, dividing by 2 is the same as multiplying by the reciprocal 1/2. Okay, but that's what similar means. So you can use it either way. And in fact, I'm going to use it both ways today. And sometimes you have to listen to the context for you to know what it means. Okay, so I'm going to give you an internet sheet to work on here in a minute. I am going to do, I'm going to give this, let's see, how do I want to do this? No, I'm gonna do this. I'm gonna give this to you in a minute, but right now we're gonna do these together. So what I would like you to do, let's see, crazy. This is a little bit of a Mad Lib, and we'll say you're gonna see one like this in a minute. When it asks you for the adjective and the noun, I don't care what you put in. It's just meant to make it fun. Notice it says a crazy dog and an intelligent teacher at the top. It's just doing a little Mad Lib here. The first couple of problems you're gonna see are almost the same. I want you to write down what I'm doing on the screen. And then you're going to see a similar one in a minute. You can do. I'm also going to put you in breakout rooms. You can talk to other people if you get stuck on one, and maybe they can help you set it up. Somebody might have to share their screen. Somebody might have to annotate and write on it. But it's I found that just sitting in a room with other students, like you're sitting around the table, might be helpful. But I want to do a couple quicks to begin with. So either on the separate sheet of paper, or like I said, we're in the book on page 13, I think. See if I can find a big blank page there. Yeah, maybe right at the bottom. Oh, wait a second. That's the wrong book. Our other book. Page 13. There's our hippo from the other day. Oh, page 15. Page 15 is a big blank space. So you might just want to write these down. And one of the reasons I'm doing this is I gave some problems on Friday, I guess, that were in the book. And some people were very confused. And then I looked at it, I was like, well, this is assuming you remember how to cross multiply from previous years. And I'm assuming you learned it. Maybe you didn't. But even if you learned it, maybe you forgot how to set these up. And once you learn how to set them up, it'll come back to you. And it's a really powerful tool. It's actually kind of one of the best things you can learn in math, up there with figuring out percentages and doing area. I mean, solving algebraic equations, probably won't do that often when you're out in the real world. Occasionally you will, but proportions come up a lot. So everybody should be writing down what I'm doing on the screen, and then you're going to get similar problems in just a minute. Notice I use the word similar because you're going to get problems that are like this, but not exactly the same. Okay, so these can either be related to rates, which a lot of these are, or if you look further down, you can see they're related to figures that are similar, okay? So that means, you know, one's an enlargement, and in fact, I think somewhere down here, oh, reduction. Once again, that's a similar figure, okay? It's a dilation. So crazy dog can travel 36 miles in 27 hours. So if I do 36 over 27, that's a ratio of miles to hours. That would work. Now, the only way I can set this up wrong is to put my other number in the wrong place. That is hours. If I do not put it across from hours, this will come out wrong. And first of all, notice my numbers here. 37, 6, and 27, that number is lower. So I would expect my miles number to be lower too. If I don't get a number less than 36, I made a mistake, because if my hours went down, my miles should go down. So that is a check that you set it up right or not. If you ever get an answer that just to make sense, you either set it up wrong or you typed it in your calculator wrong. Maybe you didn't finish. So this is one way to set it up. Another way to set it up, which will give me the same answer just so you'll see it, is I could do miles and hours across from each other and say 36 and 27 in kind of the first half of our problem, compared to, I don't know how many miles, to 15 in the second problem. Notice either way I set it up, I'm going to end up multiplying the 36 times the 15. So as long as you kind of get your matching or corresponding parts together, it'll work. Somebody just put something in the chat. How did you know how to set up the equation? Okay. I didn't, I guessed. I just said, oh, I have two parts here. I got miles an hour. I know that's a ratio. So I stacked them on top of each other. And then I know, well, for this to be a proportion, the other side has to be stacked the same way. So if they'd given me, not given me hours, and X would have gone on the bottom, and they had given me miles, would have gone on the top. And so at this point, I'm going to definitely drag out a calculator and say, okay, 36 times 15 is equal to 27 times X. And so 36 times 15 is equal to 540. And 27 times X is that. And then my last step, whenever I have a coefficient left over, I need to get the X alone. I divide by 27 and divide by 27. And I got 20. So this is 20 miles, which that seems right to me because look, I had 36 with 27. So when I go down to 15 hours, I'm expecting something lower than 36, but not tiny. Like if I got in 1, that wouldn't make sense. It still needs to be bigger than 15 because 36 was bigger than 27. All right. And let me see what I just got a note in the chat. So 540 is the 27X, and then I got to divide by the 27. And that's the other clue. Like I might not finish. So if I think, oh, 540, that doesn't make sense. I must have either set up something wrong or I've got one more step to do. So I had to divide by the 27. Thank you, Barry. All right. So I'm going to clear all this, and let's just check to see if this is right. So I'm going to hit 20. And I'm going to check. I got one right. So I got the check up there. All right, so I'm going to do 2 more here, and then I'm going to let you work some. I know I've been talking for a while, but I really want to make sure you see. And one of the reasons I'm recording this is so if you want to go back and look at it again, you can. Okay, next one. In this one, 36 and 28 hours. Almost the same problem. That was bizarre. Slightly different. But in this case, I'm saying, oh, you went 45 miles. How long did it take? So here I'm looking for hours. So once again, I can set this up any way I want. If I grab the 28 first and put it on top, that means hours is going to go on top. Now that's paired with the 36, which is my miles. So once I set up the left side, I only have one choice for the right side. Left side, I got to choose. I could have put miles over hours. But now on my right side, I've got to do miles below the hours. Otherwise, my proportion's not right. I'm not setting up corresponding parts. Okay, so 45 is miles, so that goes in the bottom. And I'm looking for the number of hours. One second, I got something in the chat, so I'm going to check on that. I haven't put the link out there yet. Nobody has a link. Everybody should just be writing this down because I didn't want people to have to jump back and forth. Okay, so we do the cross multiplication. Except I got to, why is this not drawing? I'm going to do cross multiplication. Try it again. Okay, I'm going to multiply those two together. So 20 times 8 times 45, definitely going to need a calculator for that, I think. And I'm going to do the 36 times the x. Okay, so do this on the calculator now. If you get fancy, you can do this all in one step, but I'm going to do it in 2 steps so you can see. Okay, if I've multiplied correctly, this is 1260. That's equal to 36x, and I want x alone, so I'm going to divide out the 36. And when I do that, I get 35. Now, does that make sense compared to my answer? So 36, 28, 45 miles, that was bigger than the 36 miles. So this should be a number bigger than 28, which it is. It's not a ton bigger, which makes sense because 45 is not a ton bigger than, so that seems reasonable to me. I always like to kind of do that because otherwise I could have set it up wrong. Easy to set these up wrong. You got a 50% chance of setting them right, 50% of setting them wrong. So we got 45, check that. And it's right. Oh, wait, no, it's not. What did I do? Oh, because I typed in the wrong answer. Not 45, 35. Didn't check. Notice no check mark because I didn't get it right. Okay. All right, let's do one where it's similar. So down here, I got a triangle with a length of 18 and a width of 45, similar to a rectangle with a length of blank and a width of 20. So if I was going to draw this picture, you would definitely want to draw the picture too. I would do, let's see, say 18 and 45. And then I've got another one that's a little bit smaller. That's 20 and x. That's what this describes. Doesn't matter which one's the length and width, as long as the 18 and the x match up with 45. You don't have to draw the picture, but it's nice. So once again, I can do 18 over x equals 45 over 20. I can do 20 over x equals 45 over 18. I'm just going to pick a pair, and then I've just got to get a matching pair in the other ratio. So I'm going to do 18 over 45 equals x over 20. If I do not get a number that's smaller than 20, I know I've made a mistake because it doesn't match up with my picture. So 18 times 20 equals 45x. I'm going to divide, get my calculator out. 18 times 20 is 360. And 45x divide by 45. And I better get something smaller than 20. 8. Okay, so that's going to be 8. I know I got something in the chat. I'm going to clear all this out. Actually, I'm not. I'm just going to hide that right here. You think it's 8. You check. Okay, I got 3 right. Okay. All right, so here's what's going to happen. We got about a half hour left. I'm definitely going to put you in chat rooms for about 20 minutes, and depending on where people are, we may or may not do this quiz. I want to make sure you have enough time to do this, get 4 or 5 of them right. And some of you, if you're quick at these, you may get all 10 done in 20 minutes. But I definitely want you to get some practice and realize how to set some of these up. So once again, and I'm going to stop sharing for a second. I'm going to stop recording for a second. Oh, that's not what I want.